Welcome back, guys. This is part 2 of the Chapter 11 APES lecture. So Section 11.3 is all about what are the effects of using these mineral resources. Well, a lot of it's going to be based around the extraction process. We're causing soil erosion, producing huge amounts of waste and air and water and soil pollution, all through the extraction process. So when we talk about the life cycle of a mineral, it's much like the life cycle of a product that we looked at in the fall, where it comes from extraction to processing and manufacturing the actual product, and disposal and recycling of the waste. So all of that's going to carry a lot of fresh water and energy and going to produce a ton of pollution and waste. And like I said before, most of our high-grade ores are gone, and we're kind of stuck looking for the rest. So the next couple of slides are going to talk about different mining techniques. They all have strengths, they all have weaknesses. Surface mining is kind of what we think about when we picture an old school coal mine. So they're shallow deposits. So open pit mining is going to be like if you've ever seen a quarry. There are quarries where we dig out big deposits of granite and limestone and things like that. That's going to be a good example. And then strip mining is going to be extraction of resources basically in horizontal stripes near the Earth's surface. So you go underground. It's called surface mining, but it's just below the surface. And you're pulling out strips of whatever your mineral is. Strip mining, of course, has a couple of smaller gradations or types of strip mining, something along those lines. So contour strip mining is where you're going to terrace sides of mountains. We do that a lot with coal. We do it like the columns on the Pantheon in Rome were cut out of the side of a mountain. That'd be an example of a strip mine. And then mountaintop removal, blow the top off of the mountain, you harvest it, and then you rebuild the mountain. So we'll spend a lot of time looking at mountaintop removal mining and all the negatives it has. But those are kind of the strip mining techniques. So we looked at what happens if the mineral is on the surface or right below the surface. If the mineral deposit is far below the surface, we call that subsurface. Sub always means below, so below the surface mining. So that's where deep shafts are dug into the ground to remove the minerals. So that if you've ever seen, there's a movie with Matthew McConaughey and Christian Bale. It's about dragons, and the name of it is escaping me. But it starts out with they dig too deep while they're mining in London, and they dig too deep, and they unlock this, or they let this dragon out of its keep, or something along those lines. Rain of Fire is what it's called. So in that movie, they were digging these really, really deep shafts. They're really trying to get, I don't even remember what the mineral is, but the mineral deposit is really deep within the earth. So that's definitely going to have a different set of issues than surface mining. You're going down, so you tend to not go as wide. So your surface area is less. But you're going to have more things like cave-ins and explosions and fires and lung disease because you're down deep in the deep within the Earth's surface, if that makes sense. Then subsidence is where you get like a cave-in, basically. There's a big void under the ground, and the surface, the dirt on top of it, is too heavy. So subsidence is when it collapses, basically. We get tons of solid waste from no matter what type of mining you're doing. You're going to get a ton of solid waste. It's one of the biggest causes after agriculture of air and water pollution. 40% of western mountain watersheds are polluted through mining. We all drink fracking water in our water. We drink fracking chemicals in our water. 50% of the toxic chemicals that are released in the atmosphere are done through mining. And then, of course, severe environmental impacts are going to happen when the regulations either aren't enforced or are too lax, either one. So it's really bad. If farming and agriculture and animal agriculture is the number one cause of environmental degradation, mining is number two. Some studies would say that mining is number one and agriculture is number two. So once we have pulled this stuff from the earth, then we got to do something with it. And processing these ores have, if not the same, then worse environmental impacts as extracting them. So tailings are going to be the waste rock left over after the ore has been extracted. And so picture a coal plant receiving a whole bunch of coal. Well, they don't want to burn the rock because the rock is going to make ash. That's going to make more pollution. That's going to cause less energy efficiency, and it's going to be less profitable. So they don't want to burn the ash. So they have to separate the rock from the ore itself, from the coal. So they're going to have to chip away at it. Sometimes they're going to have to dissolve it. But that stuff is going to sit somewhere. And then smelting is where we're going to melt these things down, and we're going to do something with it. So example, when we use heat and chemicals to extract ores like sulfur dioxide, we pull that out of a rock. And that always results in huge amounts of air pollution. Tons of stuff evaporate off when we go through that process because you're talking about really high temperatures. The last section of the chapter is all about how can we use these resources more sustainably. And it's the same thing as everything else. Use less, reduce, reuse, recycle, right? Reduce our use of brand new technologies and things like that. I'm getting ahead of myself. So how can we do it? Well, reduce, reuse, recycle. So a possible solution, just reduce what we're making things out of. Stop using these minerals. When I was in Rome, I toured around and I saw all these crazy marbles that are gone now. They used so much of this marble that is red and is green and is orange that it doesn't exist anywhere other than there. Well, that wasn't necessary. It's super pretty. Don't get me wrong. It's beautiful. But that wasn't necessary. They could have painted marble. They could have stained white marble. They could have used a different rock to make St. Peter's Basilica, but they didn't. They chose to use the rare minerals. So when and where can we choose to substitute? Can we afford to replace metals with silicone? I can tell you my wife loves her silicone muffin tin. She doesn't use metal muffin tins anymore. She uses silicone. It works better, it's cheaper, and it's easier. So that's a great example of a place that we could replace a rare earth metal with something like silicone that's plentiful and is easy to process. Things like fiber optic cables, we don't need copper. We can use other types of wire. We don't necessarily need aluminum wires. We can use plastics in many new ways. But remember, plastic comes from petroleum, so that's not a great answer. It's an answer, but it's not a great answer for replacing some of these minerals. But yeah, reduce, reuse, recycle, right? So can use them more sustainably. Again, we can reuse these metal products. If the motherboard for one computer will work on another computer, we pull it out and plug it in. We don't have to make a new motherboard. If we can redesign manufacturing so we can use fewer resources in the production process, then that's of course going to reduce mining subsidies. Of course, we want to angle our subsidies towards our goals and not reflect our economical values. Maybe we don't always want to do that. Seems like from an environmental perspective that would be an altruistic goal. Set our subsidies to where we want to be, not where we're coming from. So yeah, that is the end. Again, if I could leave you with anything, like always, reduce, reuse, recycle.